Programming with the Ramda.js, and I'm going to cover some basic functional programming theories as well. And so just some fun facts. I'm John, and I'm a front-end engineer in DOAS. We are a digital wealth solution platform, and you probably heard many others, but so we are another, and we are doing some wealth management stuff, enable you to access world-class shared fund house with a fractional cost. And our front-end stack is highly relying on functional programming, and we don't have Lodash dependency. We don't have a lot of imperative stuff, especially in our selectors and also the reducers. You know, because of the nature of React and Redux, the unidirectional way of flowing your data and the way that Redux handle the events using the event sorting pattern. So we think functional programming fitted very well with the reducer and the selectors. So I'm going to cover those and give you some code snippets as examples. Sorry, my clicker is not working. OK, great. So what is functional programming? So it's just a programming paradigm, so mapped from a lot of mathematical functions. So a lot of people making the jokes that how to learn functional programming, they will say, oh, just get a PhD of computer science or PhD of mathematics, then you know functional programming, which is not necessarily true. And so today I'm going to try to sell some of my 2 cents about why functional programming could be something you should look into that. And so functional programming is more about being declarative, expressive. You don't care about how to achieve something. You care more about how are you going to transform the data and what are you going to do with this stuff. So, you know, if you have written Java, like some other object-oriented stuff, like those procedural programming, it's more focused on, I get specs from the product manager and look into my code base. How can I tweak my code to achieve this goal? But with the functional programming, you care more about being declarative. You care about reuse of your functions. And the function is a first-class citizen in this paradigm. So this is just a snippet of one of the early joiner of our team. And one day he just opened the code base for the first time, and he reads the code. He's like, wow, this is really cool. Everything seems very elegant. So if in the traditional way of handling try catch, you'll probably spend a lot of lines just to write a try block. But after that, you can actually, you have to have a catch block. Then you have a final block or something else to get the error code from the object. So with the functional programming stuff, you can just basically do it with this way. So you try catch, you try to parse the JSON, some string to JSON object. If it doesn't work, you give a default value, which is an empty object. And after that, you pass that value to this function. It takes out the error code from that object. So it works just like that, and it's like writing an article. It's very expressive. Yeah. So the first thing I want to share about functional programming is purity. So pure is very important when you're writing a function in the functional programming paradigm. What is pure? So it basically means when you give the same input, it always generates the same output without producing any side effects. So it's just like a math functions. So give you some really simple example. You have a function that is add. It takes in 2 parameters, a and b, and you just sum them together and return that. So if you evaluate them for 2 times with the same arguments, you're going to get the same output. So this is pure because it doesn't modify anything that is shared. It always gives you the same output. The huge benefits of that is that you can easily do memorize, you can easily do testing on top of that because it's pure. So the next example, I'm going to show you what is impure. So this function declared with the let syntax is a mutable, and we assign a primitive number 1 to it. And in your increment function, you actually take out a parameter n, and you just sum a and n, return that. But meanwhile, you do the plus equals, so your a is mutated. You are modifying a shared state out of your function scope. So if you evaluate increment function with the same parameter for 2 times, you generate a different output, 2 and 3. So this is impure. We should try to avoid that when you are writing some functional stuff. But it's very difficult in practice, actually. So another 2 examples using the built-in array functions. So slash is actually a pure function because this code actually takes out the first element from the array 1, 2, 3, and it returns you a new element that is inside an array. So it doesn't modify the original array. But if you look at the impure function, which is splash, we seldomly use that, but actually it's one of our interview questions. So splash basically takes out the first element, and it returns you the first element, but meanwhile it modifies the original array. So your original array becomes 2 and 3 instead of 1, 2, 3. So it's modifying something outside of the function's control. So that's why it's impure. And another good example is math.random. You don't pass any parameters, but if you call it 2 times, it gives you 2 different outputs. So it's unpredictable. So that's why it's impure. And maybe it sounds something from Mars, I don't know, but actually if you are writing React, Redux, you are actually dealing with a lot of pure stuff every day, especially in your reducer. When you try to mutate a Redux store, you're not going to mutate the original Redux store. What you're going to do is you copy that entire thing and you plug the new thing and return it as a new stuff. So this is a popular example from Redux official documents. So when you add a to-do in your reducer, instead of calling state.push to add a new to-do object into the array, you're actually using the spread operator, copy the entire state into a new array, and you put the new to-do at the last position of this array. So basically, you are doing something pure. Because the nature of Redux is more like an event sorting pattern, you don't care about what's the current value of that. You care more about what are the events that is modifying my store. So because of the functional purity stuff, it's more easily for you to predict the next value, next snapshot of your store. That's why Redux just doing like this. And the next thing is side effects. So what are the side effects? So just now we talked about if you modify something that is shared out of your function's control, that is definitely a side effect. So some other side effects in our real programming life, like you read a file from the system and you write that is a side effect. Or you call a remote API to modify something, that is a side effect. And also, if your function is calling a function that has side effects, then your function is also has side effects. So I'm not saying that having side effects is something wrong. It's just something you should try to avoid that when you write your pure function or functional stuff. There are many different ways to manage your side effects in your functional stuff. Like you can use Monad in Haskell. You can use like Saga in Redux. You can use ReactJS, which is observable to manage all the side effects. So what I'm saying is that using side effects is nothing wrong. It's not forbidden. It's just that you have to be careful when you are writing functional programming about that. And so just now we talked about the purity, same input, same output, and no side effects. So this one is another important thing. It's called currying. So currying basically means you transform a series of arguments into a chain of functions that each function takes one single argument. So you keep accumulating all the arguments until you get enough arguments to generate the output. Then you return the evaluation of that. So don't worry, it sounds really alien sometimes, but I'm using some example. So add is actually a function, the same add function as we talked about just now. So instead of taking 2 arguments and sum them together, we actually write a function that takes 1 argument A and returns a function that takes in another argument B. And after we get both A and B, we return A plus B. So the benefit of using that is you can do partial application. It's going to make your function more reusable. So for example, you have a very generic add function. It can add any numbers. But what if you want to do add 1, which is increment? So you just declare partially. You just partially apply that to the add function. You do add bracket 1. And the next time when you call increment, it always add 1 into the second argument. So it's the equivalent version of calling this add bracket 1, bracket 2. That's currying. So you may be wondering why I should bother about currying when I write a function. So because currying enables you to write a lot of point phrase style code. Some in Wikipedia it's called tacit programming, I think. Yeah. So I'm going to show you some code snippet that is doing point phrase. So this is a water function. It takes in a parameter, and count is a function from Ramda. You can think it as a switch condition stuff, and so it actually takes in a parameter and pass it to the first predictor, which is equals 0. So you basically testify that whether this parameter passed into water function equals 0. If it's truthy, then you return water phrase at 0 central degree. Then, if it's not 0, you actually pass the argument to the second one, which check if it's equals to 100. If it equals to 100, you return water boils at 100 central degree. And the last one is a placeholder from Ramda, is a cap T. It means regardless of what you are passing to me, I always return true. So this is like a default statement in a switch block. So this means, if it's not 0 or 100, I just using the string template to print that value. And the same for the second one, it's eligible to vote. You're taking a parameter age, and you pass it to is over 18, and pass it to a citizen. If both of them satisfy your predictor, you return true. So if you don't use curry, you are going to write it in this verbose way. So you basically just stupidly passing the same value to the second position of the argument. Yeah, just like that. So you are repeating yourself many times, but it doesn't help much. So that's why this is called a point freestyle, where curry can help. So when your code base grows larger and larger, you'll find out if you use point freestyle, your code base is going to be cleaner and more readable. Of course, the downside is that if a person doesn't have enough functional programming experiences, he could get lost, because he will look at this code, see, oh, this looks like a good article. It's really expressive. It's very clean. However, where are we passing the arguments? I don't know. I didn't see anything. I didn't see arrow function. So yeah, so basically that's currying. Yeah, so yeah, maybe you are still feeling lost if you don't have experience in curry, but just spend 1 or 2 hours reading some Ramda documents or YouTube videos talking about curry. You'll find that it's nothing. It's just some mathematical stuff to make your code looks better. Okay, so this is an example from our production code. So before we apply functional stuff, you can see we use switch block. Basically, it takes in a risk tolerance and returns some properties for our front end. And yeah, this is quite long. I didn't count how many lines are that. But if you look at the functional way of rewriting that, so we just call it a derived slider properties from risk tolerance, and we are even using memorize for that. Why? Because when we are writing pure function, we are confident that giving the same argument, it will generate the same output. So you can sacrifice some memory space to increase your evaluation speed. One common interview question being asked in those companies are like, write a program to generate Fibonacci numbers. So if you use this pure function stuff to evaluate that, you can just wrap it with memorize stuff. So it can reduce the time complexity, because you memorize the arguments. If you hit the same arguments, you don't bother to evaluate the logic. You just return whatever is stored in the memory. Okay, so the last concept about functional programming I want to talk about is function composition. This is a key thing in function programming. So function composition basically means you are applying a series of functions, and the second function, the later function, always takes the return from the previous function. So basically, you are chaining an evaluation of that. And if you write it in an imperative way, which is at the left-hand side, if you're a Java developer or Python, you'll probably see this many times. You actually pass the x to a method f, and you get the result. You pass it to method g, and you pass the result to method h. So you nest a lot of brackets. And with a functional way, you basically just say compose. Because compose in math is from right to left. So you read that function from right to left. It means, oh, I evaluate x with f, I get the return and I pass it to function g, and I get the return, I pass it to function h. As you can see, it's easier to read. That's the first thing. The second thing, you focus more on implementing your data transformation functions instead of how you achieve your goal in an imperative way. That's the key difference between functional programming and procedural, or say, imperative programming. So I'm going to give you an example of composition. So you get a function f, actually it's a brush something to blue. And you get another function g, return Will Smith. And you apply that function, you actually get Aladdin. Maybe you haven't watched that movie, but I haven't watched it as well. I just get this picture from Reddit. So this is actually a function composition. And if you write it in program, it's just simple like this. So you have a compose from right to left, and to Aladdin function is compose f and g. So you just call to Aladdin, you pass a person to that, then you become Aladdin. That's it. So you care more about how to transform that. And some people may be picky here. Oh, you are doing it anti-human because why I have to read it from right to left? It's fine. You can use PEP from left to right. But if you want to looks like more elegant, you just do compose. Just to pretend you are really good at functional programming, just use compose. Yeah. Okay. So some more examples in our production code. This is from our selectors. So if you are familiar with selectors, basically it takes in a state and it generates some values you can use in your components. And I have nothing to explain here, but it's just expressive. The code tells what it does by itself. So one benefit is that, for example, for this snippet, maybe a little bit too small. I actually don't know how to zoom, sorry. So so basically you have get is portfolio self-selected. You have get portfolio ID. So if you look at the compose, both of them share the function called get investment plan. So that's the beauty of functional programming. You tend to make your code more reusable. And when you compose that, it works like a magic. It works like you plug all the pipeline together, you just bring in the water, it somehow just flows to the end of your pipe. You don't care what's going on in the middle. So so that's all about functional programming. The last awkward thing I want to talk about is functor. You may feel why I'd bother with a functor because it sounds like another idiot to me. But a functor basically means so the simple definition of functor is that something you actually have an object has a map method. That's a simple way. It's not always correct. So the better answer is a functor actually is an object based functor laws. So the two laws are identity law and associativity law. So I'm going to give you two really simple code examples to demonstrate what they are. This sounds fancy, but they are really simple. They are created by some mathematical PhD to try to scare our like me, like average person. But actually, it's not difficult. So so identity law, it means that you have an array of elements and you have a map method. So you just return itself in your map function. If it generates the same thing as your original array, for example, it means this obeys identity law. Basically means your map doesn't do anything magically. So this is identity law. Just apply the map function to return itself. The second law is associativity. So associativity means, for example, here we have a function f. It takes in x and plus 2. And the function g takes x and function f multiplied by 2. And the function g plus 2. So you just do this. You have something you want to evaluate if it's functor. You just call the map function of that and apply g. And then you call .map f. So basically, in this case, you basically plus 2 here, which get 4. And you map it by multiply 2, so you get 8, which is this one. And if you look at the right side, instead of chaining the map of itself, you just do it in one map by composing all the functions. So if you get the same output, which is the same output here, basically, so you compose g first. So g means plus 2, you get 4. Then you compose f, so you get 4 multiplied by 2 is 8. So your the left and the right of your strict equal sign are actually the same. So this is an associativity law. So array in JavaScript is definitely a functor. Some people say promise is also a functor because you can chain dozen, but strictly speaking, it's not really a functor. You can search on Google. There are explanations about that. And the last, I'm going to show you something really fancy. This is something I have never seen before until I worked on an open source project about blockchain. It's one of the biggest blockchain wallets in the world. So their code base is entirely in JavaScript, but they are doing a lot of Haskell stuff in the JavaScript. That's amazing. So this is something I learned from their code base. They use a class type called a tagged union. I'm not from mathematical background or computer science, so I have never really learned this concept before. But after learning their code base, I found it's really amazing. So basically, tagged union, someone call it disjoint union or sum types. So it basically means you have something, you can declare different types in an object. So it's not like Java. Java, if you define a class, that class itself is a type. So in this way, in tagged union, you can have an object. That object can contain different categories, different types. When you use that object, you can only use one type of it. So I'm going to talk about why this is really amazing. So in your UI design, for example, if you are calling an API, you tend to design 4 states if your designer is good. So you have an initial state, you have a loading state, you have a success state, you have an error state, right? So this is an actual design of our product. So we have in our reset password flow, after user clicks the reset password link in the email, the React app is actually at the initial state. So the component did mount will trigger the action to verify the one-time URL because you want to make sure it's safe, it's not expired, right? So you call an API. Basically, when you are calling the API, it's loading. And if the API say, oh, this URL, this reset password token is not expired, it's still valid, you show this success page to enable users to set his new password. Otherwise, you show a failure, you show an error message, say, oh, your token may have expired or something. So this entire process is an asynchronous API call. And to use tagged union or sometimes to solve this problem, we are using a library called Daggy. So there's a function called tagged sum. You can declare something just with these 4 types inside the object. Not ask loading, failure, success. That's it. So how does it work with the React Redux? So in your reducer, you have a not asked function mapped to an action, and when it's invoked, it actually mutates the value of this remote object to not asked. So for example, when your component is rendering, you just set it to not asked because you are not calling API, you haven't called the API. And then if it's loading, you just set remote.loading. If it's success, you just call it remote.success, pass a payload to it. And if it's failure, you pass remote.failure with that. That's it in the reducer. And we are using Saga to manage our set effects. So I'm showing a code snippet of Saga. So this one, we get a reset password token from action payload, and we call the loading function, loading action. So the loading action will flow to reducer, and it will call this one, the loading. So it will set to remote.loading. And if the API returns success 200, you basically put a success action and bypass the response into this action. So it flows to this method in your this block in your reducer. You basically set remember we talked about that. This is an object can have different types. So success is one of the types. You're basically setting the type of that value. And if there's something that unexpected happen, you just set a failure. So it comes to this code block in your reducer. You set it to failure. So then you're gonna come back to this UI design. So after you get all this, how are you gonna use that to render the code? So it's just as simple as this. You use a selector to get the remote object, and you call this category function. So category theory is another big stuff in functional programming. I'm not an expert, so I will not talk about it. But basically, you call this category function. You say, oh, if this remote object, this type class, if it's success category, I render password form. If it's not asked, I show a loader. If it's loading, I also show a loader. If it failed, I show an error message. So this 4 status actually mapped to this React design, this design for the React. It works just seamlessly like that. So all our API calls are actually relying on this remote object. And you can even chain that. You can chain that to make it look like a monad. So you can chain that like your render function say, oh, if verifying reset password is success, you actually render set password form. In your render password form, you can make it as a category. So if you haven't, after you successfully verified your password, reset password token, you render this. And before users start setting the new password, you actually render this one. This is a form. This is the reset password form you were seeing just now. And if user clicks set my new password, it will just show a loader. If it failed, it will show an error component. If success, it will show a success component. So you can chain this stuff. Your designer may like this, workflow design all the time, but for developers, if you don't use this kind of, category type to implement that, you'll probably end up with a lot of switch case, if else check, if this status is that, I render this. But with this remote object that we are doing here today, you can easily do this category or conditional rendering easily, because all your design basically just follow these 4 states. That's work very well with tagged union. And if you search on Wikipedia, there's another type called product types. That is something else, but if you are interested, you can just do it by yourself. And so one of the last thing is, I didn't really touch a lot of Ramda, but in the code snippet, actually all the functions are from Ramda, most of them. So I actually like to use the productivity tool when I implement Ramda. So I'm an off-red guy. Sorry, this is not clear. So I'm an off-red guy, and this is just the off-red. So if you want to search for a Ramda function that you know the function name, but you don't know the exact arguments, you just say Ramda, what is when function? So it tells you, oh, it's the test final argument by passing into given predict function, blah, blah. If you hit enter, it will just open the documents of that easily. It's really my work body in everyday coding life. And if you want to do something fancy, you can even say, oh, I don't know the exact name of this function, but I want something takes in an array, and it gives me another array. Am I doing any typo here? Yeah, so you can say, I want an array. It gives him another array. So it actually shows you all the functions can achieve the function signature you are asking for. This is really cool. And I love off-red. I'm a paid user. So I think that's all. And yeah, with that, I end up my Meetup session. Yeah, thank you. So any questions? I'm not an FP expert, but I will try my best. Yeah, please.
I just got a question. I just want your comment on the conjecture that although doing your coding the functional way will make it more expressive and more predictable. At the same time, it makes it less readable, especially if you're in a team where not everyone is in the same level with functional programming, basically. So I just want to get your comment on that. Like, how do you handle it?
Right. So actually, that's a really good example. Good comment, good question. So we did face some challenge, but we were having 3 front-end developers, and we are getting 1 more. And 1 guy left. So all of them so far actually are enjoying a lot of learning functional programming. I think because of nature of functional programming it's actually enforcing you to think more when you are writing program. So people really enjoy that. But to business people, they are like, oh, why you are, if they don't know what is functional programming, they may be like, oh, why you are rewriting your code into functional stuff? What is the business value of doing that? So that part, I would say, is more challenging than asking your developers to do functional programming, because usually your developers will be like, oh, this is something new, really cool, I will learn that by myself. But for business guys, they are like, don't bother do that, just deliver what you want, our customer will be happy. Yeah. So that's actually a challenging part. But if you really want to know how to handle that, I think hiring the right people is very important. If you hire someone that is really lazy, he doesn't want to do anything new, it's never going to happen if you ask him to learn what is carry, what is composition. That's impossible. I think that's probably be my answer. But learning functional stuff is really interesting. I enjoy myself of doing that a lot. And I have seen our team members are enjoying doing it a lot. So they really change a lot of code into functional way by themselves. Yeah. Sorry? Yeah, definitely. Yeah, thank you. Yeah, thank you. Okay, any other questions? Okay, I think, yeah, thank you.